Now see, our next topic, that is instantaneous velocity and speed. We discussed about average velocity and speed, but that particular average velocity and speed give you idea about the how fast positions are changing during overall journey. So you are getting idea about the overall journey. Suppose you want to know about the speed or velocity exactly at a particular instant, exactly at a particular time, then what to do? Suppose you are moving in the car and you cover the distance from Ahmedabad to Baroda within 2 hours. You started at 8 o'clock and reached Baroda at 10 o'clock, and the distance covered is 100 kilometer, then we can say this distance is covered with average speed 50 kilometer per hour. But this particular 50 kilometer per hour, that is the average. That is for overall journey. But from 8 o'clock to 10 o'clock, when you complete the journey, then in between the speed of the car increases, decreases, different types of changes takes place. Suppose you want to find velocity exactly at 9 o'clock, then that is called instantaneous one. That is called instantaneous one. Now here, to find out the instantaneous velocity or speed, the concept used, that is like this. Suppose as per given example, we want to find the velocity of the car exactly at 9 o'clock. Now, during the interval 8 to 10, means during the interval of 2 hours, the average is 50 kilometer per hour. But suppose we decrease this time interval by keeping 9 hours at the center. Suppose we think about the speed of the car from 8 hour and 30 minute to 9 hour and 30 minute. And in that also, suppose the variation is there. But then after again, if we decrease the time interval and we think about the speed in the time interval 8 hour and 45 minute to 9 hour and 15 minute. But during this interval, means during this half an hour also, there is the variation in speeds. But now suppose we think about the speed during 8 hour and 55 minute and 9 hour and 5 minute, within that particular 10 minute. And suppose during that 10 minute, the speed of your car, that is constant one, and that is 80 kilometer per hour, then simply you can say yes. Now the instantaneous speed of the car at 9 o'clock, that is 80 kilometer per hour. It implies that here the concept used, that is this one, by taking smaller and smaller time interval, we consider the velocity in that particular small time interval. And if that velocity comes to constant during that time interval, it implies that at any instant in that time interval, we can say, yes, this is the instantaneous velocity. Okay. Now, here, to find out the instantaneous velocity, first of all, we have to use graphical method. We already discussed this thing. With the help of position versus time graph, one can find the velocity. Suppose we have position time graph, that is the curved one as shown in this figure, this one. Now, here the time axis is x-axis and position axis is y-axis. Suppose we want to find the velocity exactly at 5 seconds. So now by keeping 5 seconds at center, consider the time interval of 4 seconds. Means 2 seconds less than 5, means at 3 seconds, locate the position of the object with the help of this graph. Then at 7 seconds also take the position of the object. Now see here, if we join these 2 points on the graph corresponding to time t1 and t2, 3 and 7 seconds, then this straight line obtained here not coinciding with your actual graph. Means here if you calculate the velocity by taking x2 minus x1 upon t2 minus t1, then definitely that is the average velocity. But now see here, suppose we take the time interval smaller than that. Time interval is taken 4 to 6, means of 2 seconds. So here, if we take 2 points on the graph corresponding to 4 seconds and 6 seconds, and then if we join these particular points, see here, joined by black line. So no doubt, this line is not coinciding with our graph, but that is close to the graph than the previous line, this red one. Again, take smaller time interval by keeping 5 seconds at the center and take two positions corresponding to those two time, and again here join these 2 points on the graph, prepare a straight line, and you can observe that line is very close to the graph. So in this way, if you are taking smaller and smaller, smaller and smaller, smaller and smaller time interval, then definitely for a very small time interval, suppose we take time 4.9 second and 5.1 second. So interval that is of 0.2 second only. So here you will get 2 points very close to the position corresponding to 5 seconds. And then suppose you draw a line passing through those 2 points, then you can observe this thing that will be almost tangential to this point P on the graph, which is corresponding to 5 seconds. But we know this thing, the tangent drawn at any point on any curve, that is unique one. It is one and only one. It implies that now for this particular tangent drawn at point P, if we find out the slope, then we know this thing. Slope of position time graph give you velocity. But now the slope of this tangent is constant one because it is unique one. So we can say the velocity in the time interval 4.9 second to 5.1 second is constant one, means we can say yes, at 5 seconds that is the velocity. So that is the instantaneous one. This is the concept. So with the help of graph, we can find the instantaneous velocity at any instant by taking the tangent at a point corresponding to that instant on the graph, and then take the slope of that tangent, you will get the instantaneous velocity. But this is somewhat complex method. Then after, let's think about mathematical method. Okay. Suppose this particular motion given in the graph, position time graph. Okay, that particular motion is mathematically represented by the equation x equal to 0.08 into t cube. 0.08 into t cube. Now suppose we want to find the instantaneous velocity at time t equal to 4 seconds. So again here we have to take a concept same one. We have to consider two instants. Then for these two instants we have to find two positions. Then after we have to find change in position delta x in that time interval delta t, and then after we have to calculate the ratio delta x to delta t, that is the velocity. And we have to continue this process by taking smaller and smaller time interval till this ratio delta x by delta t, means velocity, comes to constant one. But here this particular process will be carried out by taking 4 seconds at center. See how. Suppose first we take the time interval that is of 2 seconds by keeping 4 seconds at the center. So we take time t1 3 seconds and time t2 5 seconds. So 5 minus 3, the interval that is of 2 seconds, and 4 is at the center of 3 and 5. Now in this equation, if we substitute t equal to 3, then we will get first position at time t1, that is 2.16 meter. Then after in the same equation, if we substitute t that is equal to 5 seconds, we will get the second position and that will come to 10 meter. Now time interval that is t2 minus t1, that is 5 minus 3, 2 seconds. And in this time interval, the change in position delta x, that is x2 minus x1. So that is 10 minus 2.16, that is 7.84. And if we calculate delta x by delta t, then 7.84 by 2, that is 3.92 meter per second. So here, see, for time interval 2 second, change in position 7.84, and delta x by delta t, that is 3.92. But we don't know whether this is constant or not. So we have to continue the process. Then after take the time interval of 1 second, means 1 time 3.5 second. For that calculate x1. Then for another time 4.5 second, again calculate x2. Then delta t 4.5 minus 3.5, 1 second. Then delta x 7.29 minus 3.43, 3.86 meter, and then take the ratio, and you get 3.86 meter per second, this second one. Then after here, the calculations are not carried out, but now you can understand the remaining calculations. So now from the table given to you in the text, table number 3.1, now directly I am taking the data. After this one, when the time interval is taken smaller than that, that is of 0.5 second, and the instants are taken 3.75 and 4.25, corresponding to these two times, as this calculation was carried out, you can calculate x1 and x2, and for that delta x turns to 1.9225 and your ratio will come to 3.845. Then after again the time interval is taken smaller, 0.1 second. For that you will get delta x 0.3840 meter. And if you take the ratio, you will get 3.8402 meter per second. Again take smaller than this one. So 0.01 second. You will get delta x, that is 0.0384 meter. And again you will get 3.840. So now you can see this thing this value and this value are same one. It implies that after this one, if you take the smaller interval, then value will be same one. So now when your value delta x by delta t that comes to same one, it implies that that is constant value. So now we can say yes, this 0.1 second is a sufficient small time interval. Smaller than that time interval need not to be taken, because after that you will get the same value. It implies that in the time interval 3.95 second to 4.05 second, so that is interval of zero point 0.1, your velocity is constant one, and that is 3.840 meter per second. But your 4 second is in between these two. So we can say yes, at 4 second, the velocity is 3.840, and that is instantaneous velocity. But this method is also complex one, time consuming one. So many calculations should be carried out. And suppose after completion of these calculations, anybody want to find the velocity of this moving object at 8 seconds, then again you have to follow this entire process. Means complex one and time consuming one. So now we have to think about the method of differentiation, which one is in mathematics. So with the help of differentiation method, one can easily calculate the instantaneous velocity. Now see, our average velocity, that is delta x by delta t. Now how we calculate instantaneous velocity? So instantaneous velocity, that is delta x by delta t. But this ratio is taken for delta t tends to 0. And this LIM, that is the symbol of limit, means you are limiting your delta t towards 0. Very close to 0. Means very, very, very small. And for very small time interval, when you calculate this ratio delta x by delta t, then it comes to constant, and that is your instantaneous one. So symbolically, you can represent this process of calculation of instantaneous velocity in the form of equation as limit. So symbol of limit, that is LIM, delta t tends to 0. This is the condition, and for this condition we are calculating this ratio delta x by delta t. But in mathematics there is the method of differentiation which says this thing: if you differentiate x with respect to time t, then directly you will get instantaneous velocity. So d by dt, that is the symbol of differentiation, and this is the differentiation with respect to time t, and this is the differentiation of x. So here x is a function, t is a variable. So we have to differentiate this function with respect to variable. Directly we will get the answer. But how to carry out this differentiation? એટલે મેથેમેટિક્સે આપણને કહ્યું કે તમારે જો આવો આન્સર જોઈતો હોય તો તમે ડિફરન્શિએશન કરો, ફંક્શનનું ડિફરન્શિએશન કરો વિથ રિસ્પેક્ટ ટુ વેરિયેબલ કરો. તો આપણું ફંક્શન અહીંયા x હતું, ઇટ ઇઝ ડિપેન્ડિંગ ઓન ટાઈમ t, એટલે t વેરિયેબલ થયો. ઇટ ઇમ્પ્લાઇઝ ધેટ કે તમે x નું વિથ રિસ્પેક્ટ ટુ ટાઈમ t ડિફરન્શિએશન કરો તો તમને ડાયરેક્ટ આન્સર મળી જશે. But how to carry out the differentiation? So many rules are there for the differentiation of different functions, but here we will discuss different rules as per our requirements. At present we will think about the first thing. If we have function x raised to n and we want to differentiate it with respect to x, then take the power in multiplication and decrease power by 1, then this is the differentiation of x raised to n. So when you differentiate any function, then take its power in multiplication and decrease its power by 1. So at present, just remember this thing and let's proceed. Now see, our equation is x equal to 0.08 into t cube. Now instantaneous velocity v, that is dx by dt, that is equal to d by dt of x. Now substitute this equation of x here. So v equal to d by dt of 0.08 into t cube. So 0.08, that is constant, keep it as it is. Then t cube. So take power in multiplication. So 3 is taken in multiplication and decrease power by 1. So here t raised to 3 minus 1. So now your equation turns to v equal to 0.08 into 3, that is 0.24, and t raised to 3 minus 1, that is t raised to 2. So now see, the important thing in this method, that is this one, you will get the relationship between v and t. And see here, when you have relationship between x and t, then at any time t you can find position x. Suppose you want position at 10 seconds, substitute t equal to 10. Suppose you want position at 25 seconds, substitute t equal to 25. At 50 seconds, substitute t equal to 50. You will get position of the object at any damn time because you have relationship between x and t. Similarly, see, very important thing that we obtain here, that is relationship between v and t. So v equal to 0.24 into t square. Now, once you get velocity and time relationship, then not only for any one instant, you can calculate your velocity for any damn instant. Suppose you want to calculate your velocity at 4 seconds, then substitute t equal to 4. Here, if you substitute t equal to 4, then you will get this answer 3.84, which we calculated previously in the mathematical method, the same one. But here, the wonder of this method is this one. Suppose you want the velocity at 10 seconds, okay, substitute t equal to 10, directly you will get answer. Then after, suppose you want the velocity exactly at 50 seconds, no problem, substitute t equal to 50. Suppose you want velocity at 50.5 seconds, no problem, substitute t equal to 50.5, you will get velocity. So this is the concept of instantaneous velocity, and we will use this method of differentiation to calculate instantaneous velocity at any instant. Clear to all of you? Any doubt in this one?